I'm Michael.
I'm Jaden.
I'm Mika.
And what we're doing is we're doing our physics demo on gravitational potential energy. So what we'll be doing is we'll be getting a rock and dropping it onto a glass, and we'll explain the results later on.
Alright, so I'm going to be putting this glass down on the ground. Walking up here to grab a rock, and I'll be dropping it down on this glass. Break it.
Okay, so the potential energy of the rock is due to its elevated position. That's how it becomes gravitational potential energy. We based our calculations off of the weight of the rock multiplied by the height of which we dropped the rock from. The rock weighed 33.4 newtons, and the height of which we dropped the rock from was 207.26 centimeters. After multiplying those together, we found that the gravitational potential energy came out to be 6,922.48 joules.
Just like that. You set the video.
So basically, when the book is up here, it's at potential energy, and as it goes down, it's still in potential energy. And when it gets to this side, that's when it turns into kinetic energy, and then it turns back into potential energy, and then it comes back down and turns into kinetic energy, and it just keeps on going back and forth.
Okay, so kinetic energy in relation to a pendulum, which also means that the pendulum is losing potential energy, but at the same time gaining kinetic energy. When the pendulum reaches the very bottom of the swing, it is at its lowest point, but at its greatest speed. This means that the pendulum has zero potential energy and maximum kinetic energy. So when the pendulum is at the top right here, it's going down, which is kinetic energy, and at the very middle, it is kinetic energy, going back to potential energy, and so on.